Here we see that we have a triangle with a side length of A on the short leg, a side length of B on the long leg, and a side length of C on the hypotenuse.
Here we have squared the side lengths A, B, and C. They are squared because they each have 4 90-degree angles and have equal sides. We now see that triangle A, B, and C is a right triangle because it has a 90-degree angle.
Now we see that by making squares out of side lengths A, B, and C, it is the same as taking side length A to the power of 2, taking side length B to the power of 2, and taking side length C to the power of 2, or A squared, B squared, and C squared.
Now that we know what A squared, B squared, and C squared are on the right triangle, we will introduce the Pythagorean theorem, which is for any right triangle, A squared plus B squared equals C squared. What is that?
Here we have a square with the 4 side lengths, length C. So the whole square area is C squared. We have divided the square into 5 sections. There is a little square in the middle and then 4 triangles surrounding it, but that's just to help you see the area better. This will also help us explain why A squared plus B squared equals C squared.
In each of the triangles, the short leg is A, the long leg is B, and the hypotenuse is C.
Now we will move the upper right triangle to be in line with the lower right triangle to create a rectangle. We will also move the upper left triangle and swing it around so that it will be in line with the lower left triangle to create another rectangle.
In the lower left rectangle, the horizontal leg is the length B, and the perpendicular leg has the length of A. In the lower right rectangle, the horizontal leg is the length A, and the perpendicular leg has a length of B. The square in the center has not moved, just so you know.
Now we can see that the entire horizontal leg of this shape is B plus A, if it were an expression. Now, because of the commutative property, we can switch those two to be A plus B, and that's what we're going to be doing in this case. So now the horizontal leg, if it were an expression, would be A plus B.
Because the horizontal leg of the lower right rectangle is the length of B, and the perpendicular leg is B, the lower right rectangle is actually a square, to be specific, B squared. And because the horizontal leg of the lower left rectangle is the length of A, and the perpendicular leg is A, the lower left rectangle is actually a square as well. And just to be specific, A squared.
Here we can see that A squared plus B squared really is C squared, because all we've been doing since we drew that C, or that square with the side lengths of C, has been rearranging the triangles inside of it. And we've made A squared and B squared out of C squared. So that must mean that A squared plus B squared for any right triangle really is C squared.